gears. With the following requirements. You will design a spur gear set, with 2:1 gear ratio, that can transmit a 3.5 kilowatts power, at 120 RPM. First, open Autodesk Inventor. Note that, the spur gear system is an assembly of 2 gears. So, create a new assembly, as shown. Autodesk Inventor provides options to design the spur gears, directly from the Design Accelerator option. Go to the Design menu, present on the ribbon. You can design gears, from the Power Transmission menu of the Design ribbon. As you can see, Autodesk Inventor enables you to design different kinds of gears, spur, worm, and bevel. Before you start, ensure that the units of your document are set to the SI system, from the Document Settings option of the Tools menu. Now, select the spur gear option from the Design menu, as shown. This will open the spur gears component generator dialog box. Here, you can enter all the specifications of the gears you would like to design, and generate their model. Now, set the following options. Select the center distance option, in the Design Guide drop-down. This will calculate the center distance, based on the rest of the parameters you provide. So, you can customize the rest of the parameters now. Set the number of teeth for each of the gears now. Set it to 20 for Gear 1, and 40 for Gear 2, as shown. This will determine the gear ratio of your gear system to be 2, or 2:1, which is the design criteria. The UL shown next to the number of teeth, and the gear ratio, stands for unit less. Set the face width of both the gears as 50 mm. The face width of a gear, is the length of its teeth in the axial plane. Now, as you are designing spur gears, leave the rest of the parameters as default. This should create a set of spur gears, as shown. Before you proceed, you will test whether the spur gears designed, can sustain the power transmission that you are designing them for. So, click on the Calculation tab of the spur gears component generator. Now, provide the power to be transmitted, as 3.5 kilowatts, and 120 RPM as the speed. Click on Calculate button. You will now see a message that says design compliance is achieved, based on the calculation. This indicates that the spur gears you have designed, can sustain the load to be transmitted. You can see that the gears are now designed. Congratulations! You have designed your first set of gears using Autodesk Inventor. Thanks for watching. Welcome to the lesson on designing the gear shafts for the spur gears we had designed. Gear shafts are used as the drive shafts, and to transmit power between the gear train and an external source. We will design shafts for each of the gears. The Power Transmission menu of the Design ribbon has an option to design gear shafts too, as we can see. When we click on the shaft option, the shaft component generator opens. We will now use this menu and provide the appropriate dimensions to create a gear shaft. We can see that one can create shafts with circular, polygonal, or conical cross-sections. We will create a cylindrical shaft with multiple sections. Each section will be created by giving the diameter and the length of the section as the inputs. We can also define the edge features, the section type, and the section features by selecting the appropriate options. Now, create a shaft with 5 sections, with the shown dimensions, and no features. There will be two end sections, with 32 mm diameter, which will act as the handles for the shaft. The central section is thicker, and almost in comparison to the diameter, of the bigger spur gear. The central section will go through the gear. This is done, so that enough torque from the shaft is transferred to the gear. There are two sleeve-like sections, between the end sections and the middle section. These will be necessary to provide enough clearance for the bearings, and to avoid friction between bearings and the central section. The shaft is now created, as shown. We will now align the shaft axis with the spur gear axis, and also position it relative to the gear. Use the Constrain option from the Assemble ribbon to do this. The Place Constraint menu allows to set relationships between different parts of our assembly. We can set different assembly constraints, make two parts, to make them coincide. Align multiple parts at a preset angle with each other. Set two parts tangential to each other. Insert one part into another. And make multiple parts symmetric to each other, about a plane or an axis. In addition to these, we can also set motion and transitional constraints. As we want to align the axis of the shaft with the axis of the spur gear, we will use the Mate option. When we click on the Mate option, it asks for two selections. Selection 1 is first highlighted, to enable us to select the first feature. The first feature, in our case, is the axis of the shaft. So, make the first selection by hovering on the shaft and selecting the axis. Once that is done, we can see that the selection 2 in the constraint menu is highlighted, prompting us to make the second selection. In our case, the second feature is the axis of the spur gear. To avoid any mistake, we will select the axis of the spur gear from the model tree instead of the gear assembly itself. This is a good practice to follow, especially when we have multiple parts in our assembly. Now, expand the tree for the spur gear assembly. Go to the spur gear part corresponding to the bigger spur gear. Expand the origin tree, and select the appropriate axis for the gear. We can see that the feature we are selecting is highlighted when we hover on it. In our case, the axis of the gear is the Z-axis. Once we have made both the selections, we can see a preview of how the shaft will be aligned with the spur gear. Click on Apply to apply this constraint. We will now have to set the location of the shaft relative to the gear. Again, we will use the Constrain option to do this. This time, we will use two surfaces as the features to set the constraint. The face of the outer sleeve will be our first selection, and the face of the spur gear will be our second selection. Set the offset to about 30 mm, so that the shaft is aligned appropriately, as shown. This finishes the creation of the shaft for the bigger gear, and its placement relative to the spur gear assembly. We will now repeat the same process to create the shaft for the smaller gear. First, we create the shaft from the Power Transmission menu of the Design ribbon. Note that the template from the previous shaft is already present. We will just have to change the dimensions of each of the sections to suit the size of the smaller gear. Now, let us constrain the smaller shaft, just like we had done with the larger shaft. But, the longer handle of the shaft should be opposite to the longer handle of the larger shaft. Rotate the shaft if the shaft is not created accordingly. Constrain the axis of the shaft with the axis of the smaller spur gear. And constrain the face of the outer sleeve with the face of the gear, with an offset of 30 mm. This finishes the design of shafts for our spur gear assembly. Thanks for watching. Welcome to the lesson on creating keys for the gear train. Keys are machine elements that are used to connect a rotation machine element to the shaft. They prevent relative rotation between two parts and enable torque transmission. We will now create keys to connect the shafts with the gears. We will use the Key option in the Power Transmission menu of the Design ribbon. First, we ensure that the design standard for key design is ISO 2491A, as shown. We can then select all the objects that need to be created when we design the key. Select the key, shaft groove, as well as the hub groove objects to be created. We will first select the references for the groove on the shaft. We first select the cylindrical face of the shaft, on which the groove needs to be made. This will be the central section of the large shaft, as shown. We then select a planar surface of the shaft as a reference work plane. We will now select the hub, on which the groove for the key needs to be made. Select the face of the spur gear as the reference work plane. We will see that the software has already placed a preview of the key on the shaft. Now we select the axial plane between the teeth of the gear as the circular reference plane. We can see that the preview of the key is already visible. We will also notice that there are 3 arrows on the key. You can select each of the arrows to move the key axially or radially, and also resize it. Good key designs will have enough size to sustain the torque that needs to be transmitted. As a rule of thumb, you can size the key to extend a bit beyond the gear, and equally on both sides. Also ensure that the key has enough clearance from the ends of the central section of the shaft. We click on OK to design and place the key. We can see that this results in grooves on the shaft, the gear, or the hub, as well as the design of a key. Repeat a similar process to create the key for the smaller gear and the shaft. Select the central section of the shaft as the cylindrical reference, and the plane at the end of the section as the planar reference. We then select the face of the smaller gear as the planar reference for the hub, and the radial face between the grooves as the circular reference. Again, we resize the key to ensure that it has enough clearance from the section ends and also extends beyond the gear. Note that we can also check the design of the key from a failure perspective by using the Calculation tab of the Key Generator dialog box. It will be similar to the design check you had done for the gears earlier. Now that we have multiple parts in the assembly, we will set colors to each of the parts so as to differentiate them easily. We select the Appearance button on the menu bar of the Inventor window. The Appearance browser will be opened as shown. Select the parts you want to color, and select the color of your choice. Note that this might also change the material of the parts, based on the option you choose, and might affect the design compliance. So, perform your design compliance checks before you color the parts. You now have parts in different colors, and you can differentiate them based on appearance. This finishes the lesson on making the keys and coloring your parts. Thanks for watching. Welcome to the lesson on creating keys for the gear. Now that we have completed designing the gear and the shafts, we will design and integrate bearings with the assembly. Before designing the bearings, let us understand what bearings are and why are they necessary. Bearings are the elements which are used to reduce the friction between moving parts. Go to Design menu, present on the ribbon, and click on the bearing in the Power Transmission menu of the Design menu. Here, we will see a pop-up of Bearing Generator. Then, click on Design, and click on the cylindrical face, and then select the cylindrical face of the shaft, as shown. Now, we can see the planar face of the shaft active. Click on Angular Contact Ball Bearings option, and select the category as all ball bearing categories. The dimensions of the bearings are ranging from 18 to 22 for this design. Give the dimensions, activate the bearing option, and select the bearing family as JISB1521 and click OK. Click OK again. We select the bearings category based on the ease of availability of the bearings. In the model tree, we can see that the bearing is designed, but it is invisible. To see the bearing, select the 2 shafts from model tree, right-click on them, and uncheck the visibility. Now just drag the bearing you see out of the shaft, and then check the visibility of the shaft's back. We can see that the bearings designed are already constrained to the shaft, axially. After designing one set of the bearings, select the bearings, right-click, and copy, as we need a total of 4 bearings, for either ends of the 2 shafts. Paste the bearings multiple times, based on required number. We will now place the bearings on the end sections of the shafts, using constraints. To assemble the bearings to the shaft, click on the Assemble menu in the ribbon, and click on the Constraint option, from the Relationships menu. We will see a pop-up of Place Constraint. In this, select Assembly. Here, we have 2 selections to assemble the bearing. The first selection should be the face of the inner ring of the bearings. Select the exterior face of the shaft sleeve as the second selection, and click on Apply. Then click OK. The bearings will now be constrained to the shaft, axially, as well as spatially. Now, we will assemble the bearings to the other side of the shaft. Click on Assembly menu, and click on Constraint option. Select the interior face of the inner ring of the bearings as first selection, and the exterior face of the shaft sleeve as the second selection. And click on Apply. Then click OK to assemble. In the same way, assemble the bearings at the 2 end sections of the other shaft too. Congratulations! You have learned to design the bearings and assemble them to both the shafts.